Welcome students. So now taking the discussion further on the networking techniques, that is important CPM. Now we will learn next thing is that is a determination of the critical path, because it's the most important thing. Determination of the critical path is the most important thing, and this critical path is going to help us to show clearly that how many activities are involved in the project, how many events are involved in the project, how much time they are going to take, and how much cost they are going to cause to the promoters of the venture. So this is a very important consideration, and we have to learn about that how we can develop a critical path. So once the network diagram with single estimates has been developed, right, a single time estimates has been developed, the following computational procedure may be employed for determining the critical path, event slacks, and the activity floats. So we have to develop the or determine the three things. Critical path. Critical path is basically the path which is the longest path to complete a project, and that can be completed in the minimum amount of time. This is a critical path, and we have to find out that path, because if you do not complete that critical path, you are not able to complete the venture. There can be a slack path also. We have to find out the event slacks also, and we have to find out the activity floats also. So what are these three things? Critical path, event slack, and activity floats. We are going to understand in the subsequent discussion, and then we will learn about how to develop a network, and finally how we can develop a critical path. So important things involved in this, right? The procedure involved in this is we have the different steps here. So first thing is calculate the earliest occurrence time EOT for each event. That's an important consideration. Then calculate the latest occurrence time for the each event. That is a second requirement. Next thing is calculate the slack for the each event, right? That's the slack for the each event. What is a slack? I will discuss with you in the subsequent slides. Obtain the critical and the slack paths. Critical path is basically the path which is the longest path, which has no slack, no cushion, minimum time. In that minimum time, that longest path you have to complete, whereas in the slack path there can be some cushion in terms of time. So we are not going to take that path. We are going to take a path which is going to be the longest path, means involving all the steps, and we have to complete that in the minimum possible time. Means time lesser than that time is not possible to be available with the implementing agency of the project. So that's called as a critical path, and slack path is the one where some scope for the, say, extending the time is there. So we are not concerned with slack path. We will be more linked with or concerned with the critical path. And then we have to calculate the activity floats. So what are activity floats? We will understand that also very clearly. So these are the three important things, right? So you have to calculate EOT, LOT, slack for each event, then critical and the slack paths you have to develop, and then you have to compute the activity floats. Now we will learn, quickly understand that what is this say earliest occurrence time EOT, how we can calculate the earliest occurrence time EOT, and for developing the EOT for the event I is basically, you call it as, this is the event I, means EOT in bracket I is the event I. For say earliest occurrence time of the event I is the maximum of the earliest occurrence time of the event K plus duration of the activities between K and I. That is the activity K and I, basically that arrow between the K and I. The one event is the K and one event is I. So if you want to find out the earliest occurrence time of event I, so you have to find out the duration between K and I, right? And maximum of the earliest occurrence time of the event A, event K, and the duration between K and I. So this is the formula. With the help of this you can calculate the earliest occurrence time. So it clearly says that EOT is of I is the earliest occurrence time for event I, EOT K is the earliest occurrence time for the event K. K precedes I. This is a very important thing. K precedes I. So it means first you want to go up to I. So first you have to find out that how much time is taken for completing the event K, and what is the duration of the time that is taken by the activity which is going to be performed between K and I, because K is the preceding event. First you will complete that, then you will go up to I. So there is an activity arrow, you call it as this, that is the activity A, or you call it as this is going to be the KI. This is going to be the KI. So means for this KI you have to find out this, that if you want to complete this activity, so this is K and I activity, right? So this is the event K, here is the event K, and here is the event I, right? You want to complete the event I. So this all is the explanation of this. So earliest occurrence time of the event K, earliest occurrence time of event K. K precedes I and there may be several Ks, right? DKI is basically the duration of activity, that is Ki, which I explained to you, that is the activity Ki. And the maximization shown is considering all activities, right? All activities Ki leading to the event. There may be different activities. So, maximum time which is taken into consideration is, that is the maximization of the shown. Maximization shown is considering all activities, that is Ki, leading to the event node I, because we want to calculate the earliest occurrence time of the event I. Similarly, earliest starting time and the earliest finishing time. So, it means why I am discussing all this, because these time estimates are very important for developing the total network structure and finally finding out that how many activities, how many events are there, how much time is going to be taken, and that will depend upon the earliest and the latest and earliest times. And then finally, we will be able to find out that how much is the correct time estimate and how the critical path can be developed. So, earliest starting time EST and earliest finishing time EFT for developing this. Earliest starting time and earliest starting time is for this IJ, right. So, IJ is basically the activity, earliest starting time of the activity IJ, that is equal to the earliest occurrence time of the event I, right, because you want to complete the event I. So, the time is the earliest occurrence time of the, or earliest starting time of the this activity Ij, and the earliest finishing time of the activity Ij. So, that would be calculated by EOT, earliest occurrence time of event I plus duration of Ij. So, this all is given to us, and finally with the help of these two models, EST Ij is equal to EOT I and EFT Ij is equal to EOT I plus duration of Ij. With the help of these two models, you can easily calculate the earliest starting time and the earliest finishing time for the different events and activities. And the latest occurrence time, this is now the next thing, is the latest occurrence time is LOT. So, for say calculating this model, you have to use LOTI, latest occurrence time of the event I, that is minimum of the latest occurrence time of event J and the duration of that activity, that is Ij. So, with the help of this model, you can easily calculate, and minimization shown here is done with respect to all the activities, that is Ij starting from I. All the activities, that is starting from I, all the activities Ij starting from I. So, with the help of this model, you can calculate the latest occurrence time for one particular event. Then next thing is the latest finishing time and the latest starting point. Latest finishing time and the latest starting point. So, they are the LFT and LST. So, given the latest occurrence time of the various events, we can calculate the latest finishing time and the latest starting time for various activities using the following formula. So, for this purpose, you have to use these two formulas, that is the latest finishing time of activity Ij is equal to the latest occurrence time of the event J, and the latest starting time of the Ij, that is equal to LFT, latest finishing time of activities Ij and the duration of activity Ij, right. So, in this case, you can easily find out, that is the process of calculating the latest finishing time and the latest starting time. So, these times are very important, that from the given information, all these in the practical sense, all these information will be given to you. So, you have to find out all these time estimates, and finally, you have to say calculate all these times, and if you are able to calculate all these times, you will be able to develop a very good effective structures, and that structure, that network is going to help us or to guide us all through the duration of the project. Then now we talk about, I was talking to you that what is a slack, event slack, or what is a slack. So, you can call it as that the slack for an event is a difference between the LOT and EOT, right. The slack for an event is the difference between its LOT and EOT. The slacks for the various events may be of a hypothetical projects. Slacks of the various events of the hypothetical project are given below. So, it means in this case we can see here, for example, when we are talking about the first event, right, first event there is no slack normally, because there is no latest occurrence time or the earliest occurrence time. So, normally these two times remain the same. We call it as, in case of the first event, because it is the beginning of something. So, it means beginning of the project. So, we say that LOT and EOT are going to be same. So, no slack is going to be there. So, the slack here is 0, And in case of the event 2, when we start going up in the project, so in case of event 2, there is no slack. So this is also zero slack available because there is no difference between the LOT and EOT. Whereas in the event 3, there is a slack, right? Latest occurrence time and earliest occurrence time is the 6. So for example, if you use for developing the network, if you use the time period as 18, so it means you are developing a slack path, not a critical path, because there is a time period, LOT and EOT, latest occurrence time also and earliest occurrence time also. So we have to largely see here that we have to use this time to develop a critical path, or if we are going to use this LOT also, so we are going to crash it later on and we have to bring it to up to this 12. Finally, this slack of the 6 has to be removed, because if you develop the network on the basis of this time period, so it means you are going to develop a slack path, and our objective is not going to develop a slack path which has a cushion for the delays. No, we want to have that path which is a very critical path, and time period which is the minimum possible time, earliest occurrence time is possible in that path. We are going to find out that path, and there maybe some cost can increase. We can say that when you are going to reduce the time and cost has a inverse relationship here. So when you reduce the time, cost increases, especially the direct cost. In developing the networks or completing the projects in the real sense, we have the two kind of the cost. One is the direct cost that is required for the material, labor and other direct expenses, and then we have the indirect cost, which we normally call as the fixed cost. Depreciation is the fixed cost, or maybe office expenses are the cost, administrative expenses are the cost, which are the fixed cost. So fixed costs are going to grow with the time. So, right, fixed cost, as the time increases, fixed cost also increases. So it has a linear relationship. But a relationship between the direct cost and the duration is the inverse relationship. If you are going to increase the duration, direct cost will go down, right? But if you are going to reduce the duration of the project, so direct cost will increase, because you have to employ more resources. You have to bring more material, more workers, more power, everything more. And when you want to have the higher amount of the input resources, in that case your cost increases. So your objective is to develop a critical path where there is no slack, there is no cushion for the delays of the project, and maybe the cost is going to increase. We are ready to pay the increased direct cost. Indirect cost is not going to be affected. That's only linked to the time. It is linear relationship. If we are increasing the time, fixed cost is going to increase. We are decreasing the time, fixed cost is going to decrease. But as far as the direct cost is concerned, we'll see the relationship in the next slide. So as far as the direct cost is concerned, it has an inverse relationship. So it is our objective. If we have the sufficient time, right, then you can use the slack path also. But if you do not have the time, and normally in every project we do not have the time, because the moment we give the time in building the project, it brings or entails the high amount of the risk. Because time element brings the risk. That we see in the payback period also, that longer the duration, higher the risk will be involved, because more unforeseen period would be involved in that part. So normally while developing the networks, we use the critical paths, not the slack paths, and there we try to use the minimum time period which can be estimated for completing different activities and consequently the whole project. And there we want to find out which activity has the slack or which event has the slack, and how that slack can be understood in advance, can be taken care of, can be removed, so that finally the network which we are going to develop later on, that's going to be the longest path, means not the shortest path. Don't try to confuse it with the minimum time period. Path is going to be longest means it has to complete all the steps right from the beginning till end in the logical sequence, but the time period to traverse that path has to be the minimum, right? So that would be called as a critical path. If the time period is not minimum, if there is a LOT, we are using the LOT, in that case that is a slack path. So if you want to create a slack path, it means you want to save the cost. But that cost may be, that situation may be highly risky, that you are going to save the direct cost, but because of some other random variable, the project may be disturbed. So always develop a critical path so that you have that finally the critical path, the final complete longest path, which is you are going to complete in the earliest occurrence time or in the minimum possible time. So this is all the slack. Slack is basically the difference between the LOT and EOT. Our objective is to use the EOT, not LOT, and we have to remove the slack while developing the networks. So now in this case, critical and the slack paths. The critical path starts with the beginning event, terminates with the end event, and is marked by an event which has a zero slack, zero slack. Understand it very clearly. The critical path starts with the beginning event, terminates with the end event, and is marked by the event which have a zero slack. This is obviously the path on which there is no slack, no cushion. Other paths are slack paths with some cushion. Other paths are we have no slack, no cushion here. This is the time period involved here is the minimum in this. Slack means in terms of the time period. Path is longest, complete path, but time period involved or we are going to estimate it, that is without slack, no cushion in the time, and the given time we have to use and we have to complete that activity in that given time and the whole project like that. Other parts are slack path, some cushion may be there in terms of time, so you can save the cost if you want to increase the time, but there can be some other maybe the side effects of it. So we should try to find out the time which is going to give us a critical path without any kind of the cushion or without any kind of the slacks. Then we have the next thing, the critical path is the longest path. I am telling you time and again, the critical path is the longest path from the beginning event to the end event, because you are going to complete all this. For example, this is going to be like this. So this is going to be the path like this is going to be the longest path, right? Because it has to take into consideration all the activities and all the events. So critical path is the longest path from the beginning event to the end event, since the end event can be reached only when this longest path is traversed. Since the end event or the end can be reached only when this longest path is traversed, the minimum time required for completing the project is the duration on the critical path, right? Understand it very clearly. The critical path is the longest path, first thing, from the beginning event to the end event. This is the longest path, because all the things we have to take into consideration, all the activities involved from the first activity to the last activity we have to take into consideration. Since the end can be reached only when this longest path is traversed, the minimum time required for completing the project is the duration of the critical path. So longest path means a complete path, and to be completed in the minimum duration is the path we are going to find out, and that path will be known as the critical path. So we can develop that path which has no cushion, no slack, and this is the going to take the minimum time period that we are going to develop. Now let's understand the activity floats. Given the estimates of activity, time and event slack, right? Given the estimates of activity, time and event slack, activity floats can be calculated. There are three measures of the float. There are the three measures of the float: total float, free float and independent float. Activity floats can be calculated. So given the estimates of activity time and event slacks, there can be three floats. The activity floats can be calculated. There can be three floats: total float, free float and independent float. And these floats help us to understand or to make the network more efficient and the most, you can call it as the representative. So the total float of an activity is extra time. The total float of an activity is extra time available to complete the activity, extra time available to complete the activity. So we have the minimum time also, and we have the final time also. So extra time to complete the activity if it is started as early as possible, right? So total float of an activity is extra time available to complete the activity if it is started as early as possible without delaying the completion of the project, right? Without delaying the completion of the project. The total float represents the float under the most favorable conditions. You are starting as early as possible and finally you are going to complete it as early as possible also. So most favorable conditions are there under which you are going to develop this float, and this float is called as the total activity float. Then free float of an activity. What is the free float of an activity? It is basically the extra time available to complete the activity when the activity is started at the earliest occurrence time of the preceding event and completed by the EOT of its succeeding event. So what is it? That is the free float of an activity is the extra time available to complete the activity when the activity is started at the earliest occurrence time of the preceding event and completed by the EOT of the succeeding event. And one is the independent float, which is going to be the independent float of the activity of an activity, and this has to be possible in the most adverse conditions. Independent float. An independent float of an activity is basically the extra time available to complete the activity when the activity is started at the latest occurrence time of the preceding event and completed by the earliest occurrence time of the succeeding event. Independent float represents the float under the most adverse conditions, right? Most adverse conditions that you are starting the first event, right? The LOT of its preceding event. So, independent float of an activity is the extra time available to complete the activity when the activity started at the LOT of its preceding event. Latest occurrence time of its preceding event and completed by the EOT of its succeeding event. So, because we started at LOT, though we completed it at EOT, but when we started at LOT means why that latest occurrence time was taken at the preceding event, because conditions are most adverse. Had the conditions been suitable, we could have completed that event in the minimum possible time, but because we completed the preceding event in the LOT in the latest occurrence time, so because of that, though we completed it in the earliest occurrence time of the succeeding event, but because of the adverse conditions, the beginning of the preceding event was at the LOT. Because of that, that float is called as an independent float, and it happens only in the most adverse conditions. So, if the conditions are favorable, either you can have the total float or you can have the free float, right? But if the conditions are not favorable, then you can have the independent float. And numerically also, with the help of equations, we can understand what these floats are. So, the floats can be understood with the help of these three equations. So, total float basically is total float of an activity, right? Total float of an activity Ij, that is equal to LOT of event j minus EOT of event I minus duration of activity Ij. And similarly, the free float of the activity Ij is equal to earliest occurrence time of event j minus earliest occurrence times of I and duration of Ij, that is activity Ij. And independent float of Ij is the earliest occurrence time of event j minus LOT, latest occurrence time of event I, and duration during the activity, that is Ij. So, these are the three important floats we have to understand that basically at what time we are starting the activity, at what time we are ending the activity, because that time period, that duration would be very carefully calculated and taken into account for calculating the total time period required for completing those activities and events, and finally including into the network structures. Now, we talk about next thing is we talk about is the PERT model. So, when you talk about the PERT model, so in this case, we are going to talk about that is the variability in the PERT analysis. It's very important, and understand it very carefully. Variability in the PERT analysis is measured by variance or its square root standard deviation. Variability in the PERT analysis. Why the variability in the PERT analysis? First of all, this is a question. Variability in PERT analysis is measured by the variance or its square root standard deviation, PERT model. Mind one thing, that when we use the PERT model for developing the networks, right? PERT model, what is the first condition where we use the PERT model? We use the PERT model in the projects which are probabilistic and which are affected by the uncertainty, and they entail or they carry the high amount of the risk. In R&D projects or in the aerospace projects or in any projects, right? In any kind of the projects where there is a high amount of the uncertainty or risk involved, right? So, it means when the high uncertainty or risk is involved, it means you have to signify, you have to mark that risk, and for signifying or marking the risk under the PERT projects, we calculate that risk by using the concept of the standard deviation or the variance, right? Standard deviation of the variance. So, what is the standard deviation? Standard deviation is variance, is basically the square root of the variance. It has a relationship and interrelationship. So, standard deviation is basically the under root of the variance, and if you want to calculate the variance from the standard deviation, so if you square the standard deviation square is basically the variance. So, we have to use this concept of the standard deviation or the variance for developing the PERT models, because the project contains the risk, is affected by the uncertainty, and to address that element of the risk or uncertainty, we have to use the concept of the standard deviation. We will have to calculate the standard deviation, and we will have to use the standard deviation in calculating the possible date of the completion of the project, right? because you are not dealing with a certain project, you are dealing with highly uncertain project. So you are not sure about, you are expecting that my project would be completed maybe by the end of this July, 31st July, or maybe something like that. But there is no one time estimate, number one. In the PERT, you see, we have had the multiple time estimates. We have the TO, TM and TP, right? So we have to take the average of that. So we have to calculate the expected time. But ultimately, expected time is also expected time. That is not the final time. And that expected time is expected time because amount of the uncertainty is affecting the model, the project, the completion of the venture. So in this case, you have to address the concept of the PERT model, you have to address the concept of the risk or uncertainty. For that purpose, we will have to use the concept of the standard deviation or the variance. And if you calculate the standard deviation of the different time periods of the different activities, right? For example, you have the 3 time estimates of the activity number 1. There is activity number 1 and you have the 3 estimates, that these 3 estimates are TO, or it can be TM, or it can be TP. Right, it can be TP, right? But these are the standard we have seen in this is activity number 1, right? Or you call it as activity number 1 to 2. So for this activity, we have the 3 estimates, estimate TO, TM and TP. These are as per our literature of the networking techniques. But in the real time, there can be 5 estimates also. We can complete activity in 3 days, in 5 days, in 7 days, in 9 days, or even 2 days, because uncertainty is there. So there can be more than these 3 estimates also. So what we have to do is, when we are going to address this particular thing, the amount of this risk or uncertainty, we have to use the concept of standard deviation. So first of all, you have to calculate you have to find out the possible times which can be taken for one activity or an individual activity, and calculate the standard deviation involved in that time series of completion of that activity, expected time of completing that activity, and this way you have to calculate the standard deviation of the duration of all the activities. So that would become the standard deviation of the project as a whole, and that you have to use in developing the critical path. So read it what is given here. Step number 1, standard means the steps involved in calculating the standard deviation of the duration of the critical path are as follows. Number 1, determine the standard deviation of the duration of each activity on the critical path. Normally 3 time estimates, but there can be more than 3. So it becomes a series to you, and you can calculate the mean, and then from the mean you can calculate the standard deviation, and if you scale the standard deviation, it will become the variance. Then number 2, determine the standard deviation of the total duration of the critical path, right, on the basis of the information obtained in step 1. So first activity, second, third, all activity wise you calculate the standard deviation of all the time durations, and then when you sum it up, you will be able to find out the total duration of the critical path. So we are going to use the concept of the standard deviation. So how we can use the concept of the standard deviation? Normally when we see that under the PERT, we have the 3 time estimates. So it is written here, for determining the standard deviation of the duration of any activity, we require entire probability distribution, as I am telling you. That is the entire probability distribution. It can be 2 days, 4 days, 5 days, 7 days, 8 days, 9 days. But if we are saying that not 5 or 6 durations, expected durations, we are using 3, right? So we, however, have only 3 values from this distribution, right? TP, TM and TO, right? We have the 3 values in this. So we can have, normally we can say that it will take most, say you call it as optimistic time or most likely time or pessimistic time. Right. So we don't say that it will be having the 4 or 5 or 6 possible times. We say we will have the 3 possible times, and anywhere of these 3 times the actual time will coincide. Maybe it can be TM, TO or TP. It will coincide and not more than this. But PERT analysis further simplifies it. It doesn't use even these 3 time estimates for calculating standard deviation. For calculating standard deviation, you can use a given model here. This is a standard model here, where it uses only TP and TO, and it divides this TP minus TO by 6 when it divides this value of TP minus TO by 6. So it gives us the value of the sigma, and this sigma is basically the standard deviation. So normally we have the 3 time estimates for completing an activity, but under the PERT, for calculating the standard deviation, which is signified by sigma, we use this particular model TP minus TO divided by 6, and finally we can use this sigma for calculating the expected duration of the completion of the project. So here you can say sigma is the standard deviation, TP is the pessimistic time, TO is the optimistic time, and variance is obtained by scaling the standard deviation or the sigma. So if you scale the standard deviation, it becomes variance, and when you take the square root of the variance, it becomes the standard deviation. Standard deviation and variance of an activity duration on a critical path. So you can find out easily that this process we have followed for the hypothetical values, and we have taken two activities, 1 to 2 and 2 to 5. So the TP is 21 and 24, and TO is the, here it is TO basically, this is TO. So this is TO is basically the 9 and 10. We are using the formula which is discussed in the previous slide, that is sigma is equal to TP minus TO divided by 6. So that way we are getting this value, and finally we are, when we are say scaling the standard deviation, so we are getting this variance value. And finally, when of this variance, when we are taking the square root of this variance, sum of these two, the variance basically when we are taking the square root, so the sigma comes up as 3.07. Sigma comes, the standard deviation comes up as 3.07, and this is 3.07 as sigma we can use for finding out the possible duration of the project. So finally, for calculating the possible duration of the project, you have to find out the Z value, right? And for calculating the Z value, you have to take these three inputs. One is the duration which you expect, that by which date, maybe by 20th of July or 25th of July or 31st of July, the project will be completed. So that date will come here. T is basically the average of that duration, right? Means the activity duration. This is the T is basically the mean value of that activity duration, and or the critical path, and then this is the average of the critical path or the duration, and standard deviation of the duration of the individual activities and summed up activities together. So it is the standard deviation or the deviation of the critical path. So to obtain a cumulative probability, so what you can do is you can have the different probabilities, and for that cumulatively you can calculate the Z score. You can calculate the Z score, and once it is already available with us, so for any kind of the date, possible date of completion of the project, if we have these three values, the possible date, then the mean value of the duration of these different activities and critical path, and the standard deviation involved in completing the say this critical path, following the critical path. So finally we can find out the value easily. So these are the values which are given to us. We have already calculated, these are available. I have taken from the book, basically from the Prasanna Chandra. These Z values are already calculated. You can refer to the book. So these values you will find in this chapter on the networking techniques. So these values are already available with us. We don't need to calculate when we have to, maybe have to calculate the possible date. All these Z values are already available for the different, so you call it as the different values of the Z. The cumulative probability value is also given to us, and we can use these different cumulative probability values for the different values of the Z, and we can find out the possible date of the, means the probability, not the possible date, but the probability of the completion of the project by a possible date. Probability of completion of the project by a say possible date. So in this case, for example, if you say that you want to complete the project by 20th of the month of a given month, and for example, so you are taking here the date in this formula for calculating Z 20, which we saw that what was this? This was basically the D minus T. T is basically the, we are assuming that the average of the project duration is basically the 28, and standard deviation we have calculated 3.07. So this comes up as minus 2. Z value comes up as minus 2.6, and at the Z value of minus 2.6, this is the Z value of minus 2.6. So this value we are going to take here 0.005. It means the probability of completion of the project whose mean value is 28 days or maybe 28. So by completing it by the 20th of one particular month, date 20th of one particular month is just, you can call it as the 0.5%, just 0.5%. If you say that project will be completed by 25th, so the probability comes up as 15.9%, and you say that it will be completed by 30th, so the probability is 72.6%. So nearer the date to the average value of the duration, more will be the, high will be the probability of completing the project. For example, the difference between this is basically of the 20 and 28 is of the 8, right? So the probability is very, very bleak, you can say, that is 0.5%. And the difference between 28 and 25 is basically 3. So the probability goes up to 15.9%, and when the difference is only 2 here, that is the 28 and 30, so the probability increases to 72.6. percent. So there is a 72.6% probability that the project would be completed by 30th of the month. So with the help of this Z score and the probability distributions calculated against this Z score, we can find out that the duration or maybe the possible date of the completion of the project after adjusting or taking care of the risk element of the risk or uncertainty involved in the project. So because PERT related projects or the projects where we apply the PERT, they are highly say uncertain or surrounded by the uncertain conditions or risk. So there you have to use the concept of standard deviation. You have to calculate the Z score, and then with the help of the Z score you can calculate the probable date or the probable date of completing the project. And for calculating the Z score, you need the mean value of those durations and the standard deviation of that duration. If you have these two values, then easily you can find out that in a project which is highly uncertain, surrounded by the risk and uncertainty, by what date we can complete the project. And then we will talk about the CPM model. So for this particular model, for the CPM model, we will be talking about the different parts and different you can call it as the structures or maybe the systems. And for this purpose, you can say that for developing the CPM model, though the CPM model is not surrounded by any kind of the uncertainty, it's most deterministic model, but it doesn't mean that it has only a single time estimate and we are not having the multiple time estimates, right? It does not mean that the CPM is only working with the single time estimate. It also has the ultimate purpose of the CPM is that we have to find out the minimum duration of the project at the given cost. Minimum cost you call it as. We have to find out a time cost relationship while working out the or applying the CPM model. We will have to find out the time cost relationship, so that for the minimum time and cost, how we can complete the project. So basically the orientation of the project means the model is deterministic and the CPM is used into the projects which are not influenced by the element of uncertainty. Still, it has many other requirements, and all those requirements must be fulfilled before applying this concept for developing the networks for the projects or for the ventures which are not surrounded by the uncertainty. But yes, many other factors influence the developing of the network using the CPM model. So this detailed discussion on the CPM model we will discuss in the next class. Till then, thank you very much.